Good day, students. So welcome to part 7 of the Integrated Regents exam review for January 2014. In this installment, we're going to be going over problems 31 to 34. All right, let's take a look at problem 31. Involves simplifying radicals. So we have to express the square root of 84 over 2 root 3 in its simplest form. All right, so let's go ahead and rewrite it. Root 84 over 2 root 3. Now, there's a property of radicals that I'm going to be using here. We have the square root of a over the square root of b. These two can be expressed as a combined radical, root a over b. Okay, so here I'm going to combine 84 and 32 and 3, since they're both they're both the radicands of the second root. Okay, so this can be condensed into 1 over 2 times the square root of 84 over 3. Imagine there's a 1 in front of every number, right? So 1 times root 84 over 3. So 1 times root 84, so I have 1 over 2. This 1 goes with a 2, and then I combine these two together to become root 84 over 3. Okay, all right, so let's go ahead and simplify this. This can be reduced. It becomes 1/2 times the square root. 83 goes into 8 2 times. Remainder 2. 3 goes into 24 8 times. So is this the simplest radical form? Well, we have to decompose this radicand completely and see if any factors repeat. If they do, they come out as 1. All right? So we're going to take root 28 to the side and see if we can reduce this. What goes into 28? Since it's even, 2 goes into it. I'm taking out prime factors. So 2 goes into 28 14 times. 14 is even, so I can take out another 2 from 14. That's going to give me 2 times 7. So 2 goes into 14 7 times, and that's that. I notice that these two factors repeat. So what is the square root of 2 times 2? 2 times 2 is 4, and we know that the square root of 4 is 2. So these two 2's come out of the radicand as 2. All right, so the square root of 28 is going to be 2. This 2 comes out. Let's change the color. 2. Now, what do we have left? The 7. How do we express it? It's going to be rad square root of 7. So it's going to be 2 root 2 root 7. So that's a simplified form of root 28. Okay, so this expression now becomes 1 over 2 times, instead of root 28, it becomes 2 root 7. Now these two 2's divide out. 2 goes into itself once, and 2 goes here once. And your final answer is the square root of 7. All right, let's move on to the next problem. All right, so in 32, it says the cumulative frequency table below shows the number of minutes 31 students spent text messaging on a weekend. Okay, so it says determine which 10-minute interval contains the median. Justify your choice. All right, so first thing we're going to do is we're going to adjust the intervals in a way that it's easy to identify the exact interval where we have the median. If you notice, all of them starts from 41, but your endpoint changes. Okay, so we have to adjust the start points in such a way that it reflects the accurate starting point. Okay, so for 41 to 50, it's 41 to 50. That's fine. That's where it stops. From 41 to 60, we already have 41 to 50. So if we take 41 to 50 from here, we're going to have 51 all the way to 60. And then if we take 51 to 60 and 41 to 50 from 41 to 70, we're left with 61 to 70. You see the pattern? This interval here is from 71 to 80. And then this last interval is from 81 all the way to 90. So this tells us exactly what the interval is for each cumulative frequency. Now to find the median, all we just want to do is want to find out where the middle total, the middle total number of minutes is located. All right. So what we have to do is we have to add up all the minutes and then find out which of these intervals has the middle amount of minutes. Okay, so let's go ahead and just simply add all of this together. So we're going to add 2, 5, 10, 19, 31. If you add that with your calculator, you end up with 67. Okay, so this is the total number of minutes. The median is basically the middle, all right? So I'm going to divide this by 2. 67 divided by 2, we have 33.5. So the question is, in what interval do we hit 33.5? If you notice, going upwards at 81 to 90, this is 31. That's a lot, right? So 33.5 must be somewhere here. So if going from here, let's just make an interval. Going from here to here is 31. First interval. How about when we go from, if we go from the end to the second interval right here. So if we go from just a little bit, if we go from down here all the way to here, how many minutes is that going to be? Is it going to include our median? That's the question. Okay, so from here to here, how many minutes is that going to be? That's going to be 19 plus 31. 19 plus 31 is what? 50, right? That is way bigger than 33.5. So we already exceeded the median. Okay. If you wanted to do it from the reverse, let's say you were going from up down. What if you started from 41 and went all the way down to 70? How many minutes would that be? That would be 2 plus 5. 2 plus 5, which is 7. 7 plus 10 is 17. Okay, so if you went from top to the bottom, you notice at this point, you have not even reached the median if you're going from the top. And from the bottom, sorry about that, from the bottom to this point, you've crossed the median. So what does that tell you? It tells us that the median has to be somewhere here in this range right here. Okay, so the median is between, take this out of the way. The median is between 71 and 80. So this is where the median resides. So right here is where the median is. How do we know? Because going from the top, if you get to 70 is 17. If you going from the top, let me just illustrate something else for you. If you're going from the top all the way down to 81, is going to be 17 plus 19. What is 17 plus 19? 17 plus 19 is 36, and that's too big. Okay, so the median has to reside somewhere in this bound right here. If you go too high from the bottom, you're going to exceed it. If you go too low from the top, you're going to exceed it. So the median has to be from 71 to 80. All right, so let's go ahead and write down our answer and the justification. So we write the median. The median is in the 71 to 80 range, since the median minutes of 33.5 falls in that interval. Okay, so 33.5 is somewhere between 71 and 80. All right, let's take a look at 33. It says Kristen invested $1,000 in an account at an annual interest rate of 3%. She made no deposits or withdrawals on the account for 5 years. The interest was compounded annually. Find the balance in the account to the nearest cent at the end of 5 years. So for this one, you need to know your compound interest formula to compute how much it's going to have. And that formula is given by the final amount equals your principal times 1 plus the rate raised to the number of time compounded a year times the total number of years you invested the money. Okay? So what do each letter mean? Let's go ahead and describe the significance of the variables. So P is the principal. Principal is a fancy word for starting amount. How much did you start with? Okay, principal is starting amount. R is the interest rate. Interest rate per year. N is the number of times interest is compounded. Interest is compounded per year. And then T is length of investment. Length of investment, okay? Length of investment in years. Length of investment. Okay, so let's see. In this problem, let's list all the things that we have. The P, the principal, what you started with is $1,000. Your rate, interest rate, now this is where you want to be really, really careful. Okay, some people might just write down 3 as your interest rate, but 3% is not a mathematical value. You have to convert it to math. This is English, okay? So 3% basically means 0.03. 3% is 3%, 1 over 100. Okay, if you want to make this over 1, you put a decimal point here, a decimal point here, move this forward twice, do the same on the top, twice, put a 0, 0.3. Okay, so just remember 3%, 3 over 100, and 0.03, they all mean the same thing, okay? They all mean the same thing. But when you're carrying out calculations, you want to use the decimal or fractional representation of 3%. You can't use this, okay? So be very careful with that. N is the number of times the interest is compounded. What does it say here? It says annually, right? So annually means once a year. So N is equal to 1. T is the length of the investment. How long did they invest the money? Or did she invest the money? 5 years. Okay? All right, and what is A? A is the, I didn't even indicate what it is here. A is the final amount. Final amount. So what is A here? Final amount or balance. A is what we're looking for, so we don't know what A is, okay? So let's put all these values into this formula, and then let's compute what her balance is at the end of 5 years. So this is a key formula you want to remember. So we're going to have her final balance, A, is equal to the principal, which is 1,000, times 1 plus the rate, 0.03, not 3, please, raised to the nt, which is 1 times 5. So we're going to have 1,000 times 1.03 raised to the 1.5. Plug that in our calculator, see what we get. All right, so you have 1,000 times 1.03 raised to the 5th power. No, this is not 1.5. This is supposed to be just 5 right here. Let me fix that. So 1 times 5 is 5. Okay, so we raised to the 5th power. And our answer is 1,159.27 rounded to the nearest cent. Okay, so this is final amount is $1,159.27. That's how much she has at the end of the 5-year period. All right, let's take a look at the last problem. All right, so for problem 34, it says graph and label the functions y equals the absolute value of x and y equals the absolute value of 2x. on the sector axis below. And after generating the graph, we are to explain how increasing the coefficient of x affects the graph of y equals the absolute value of x. All right, so we're going to start by graphing y equals the absolute value of x. If you know what your parents' functions look like, you should know what the graph should look like before ever you start. The absolute value function, they basically look like these. Okay, they're like these. And they're even functions. They're symmetric with respect to the y-axis. So to generate the graph, let's make a table of values. I'm going to make a table of values for both of my two functions, graph them simultaneously. So let's see. First thing we have, let's do, I just need 3 points. I need a middle point, a point to the right, and a point to the left. So this is x, and then y equals the absolute value of x. So I'm going to use 0 in the center, -1 to the left, and then 1 to the right. So for 0, y is going to be equal to the absolute value of -1, which is equal to 1. And then for -1, that's what we get. And then for 0, y is going to be the absolute value of 0, which is just 0. And then for 1, y is going to be the absolute value of 1, which is just 1. So if we want to graph these points, our points are going to be 0, 0, -1, 1, and then 1, 1. All right, those are all the points I need. And then let's go ahead and draw a graph for the absolute value of x. The more points you have, the better your graph will be. But we know that 2 points. We know that 2 points define a line, so basically we have a line going through those points like that. Okay, so that's for that's the right side. Now we're gonna go in the other direction. Draw a line through those the points. Make sure it's good. And then going to the right, we have the other line. It's a little bit difficult using this electronic device, but with paper and pencil, you can do it easier. All right, so there goes the point. So the 3 points we have are -1, 0, and 1. Okay, on our x-axis, you can put the numbers there. That's -1, that's 0, and then that's 1. This graph we just drew is a graph of y equals the absolute value of x. Now let's do the other one. Let's graph y equals the absolute value of 2x and see how the graphs compare. Okay, so there goes my x. I'm going to use the same pattern as I did with my absolute value of x. So in this situation, y is equal to the absolute value of 2x. All right, this is also it looks very much like this, but it's either going to be wider or narrower. 0 in the center, -1 and 1. So for the first one, we're going to have y equals the absolute value of 2 times -1, which is equal to the absolute value of -2, which is equal to 2. For 0, y is going to be the absolute value of 2 times 0. 2 times 0 is 0. Absolute value of 0 is 0. And then lastly, y is equal to 2 times +1, which is equal to 2 times 1 is 2. Absolute value of 2 is 2. Okay? All right, so let's graph the second line. So that one is going to be 0, 0. I'm going to graph this one in green. So we have 0, 0. For -1, it jumps up to 2. And then for +1, it jumps up to 2. All right, let's go ahead and draw the graph. I'm going to draw it in green also. So this is the graph of the absolute value of 2x. Starting from the origin, it goes through that point, like that. Okay, and then the other one, let's draw the second line here. Green one. All right, so starting from the origin, going to that point, symmetric with respect to the y-axis. All right, so there goes the second one. And then the line we just graphed right now, what equation is that? This is y equals the absolute value of 2x. So what happened to the graph when we changed x to 2x? We noticed that the graph compressed. It was compressed horizontally. It was compressed in this direction. Okay, so that's what happens when you increase the coefficients. It is, you have that vertical compression going, horizontal compression going on there. All right, so let's go ahead. We have it graphed. Now we also have to answer the question. It says, explain how increasing the coefficient of x affects the graph of y equals the absolute value of x. So increasing the coefficient of x. So I hope you know what the coefficient of x is here. For y equals absolute value of x, this is the same thing as absolute value of 1 times x. So the original coefficient was 1, and then the second one is 2. So we increased it from 1 to 2, okay? So that's what coefficient means, the number in front of the variable. So increasing the coefficient of x from 1 to 2, what did it do to the graph? It caused the graph to increase, to compress horizontally, okay? So increase the coefficient of x from 1 to 2 causes the graph of y equals the absolute value of x to compress. In what direction? To compress horizontally. Horizontally. All right, so that's that. So thanks so much for taking the time to watch this presentation. Feel free to subscribe to our channel for the remaining of the review installments for this review series. And more clips can be found on mathgotserved.com/testprep. Thanks again for watching and have a wonderful day.